Hello, seventh grade. This is Mrs. Lopez. We are starting our seventh grade curriculum, and we are in module one. Everything about proportional relationship we are going to learn, and this is lesson one, an experience in relationships as measuring rate. In this lesson, in this module, we are going to learn a lot about proportional relationship and a vocabulary that we need for it um, is pretty extensive. So we need to make sure that we know the basic words to be able to solve the problems. So let's review the vocabulary. A ratio. A ratio, and I'm going to circle it. A ratio is an ordered pair of numbers which are not both zero. A ratio is an ordered pair. You actually need to underline this and remember because later when we get to graphing on coordinate planes, you will need to know that the ratio is an ordered pair, um, and they're not both zero. A ratio is denoted A to B to indicate the order of numbers. Number A is first and number B is second. The ratio can be expressed as A with the column B, A over B, or A to B. So different ways to express our ratios as a column, as a fraction, or just using the word two. Two ratios, A to B and C to D, are equivalent ratios. Equivalent ratios, that's another vocabulary word that you need to learn. If they both have values that are equal. For example, ratio 1 to 2 and 3 to 6 are equivalent because their values are 1 to 2 anyways. I can simplify these fractions through 6, and when I simplify it, I will also get 1 half, right? 1 half equals to 1 half. The values are the same, so the ratios 1 to 2 and 3 to 6 are equivalent. A ratio relationship between two types of quantities that are different quantities such as 5 miles per 2 hours, can be described as a rate. So this is not a vocabulary word, rate. Rate is the ratio between two different quantities. The examples of a rate can be dollars per gallons, dollars per pounds, gallons per mile. Um, we can go as hearts per minute, heartbeats per minute. Um, many different rates that we can come up with. And another word that you really need to know is the unit rate. We will talk a lot about that one. The numerical part of the rate is called the unit rate. So if we say there is a rate of 5 miles per 2 hours, the unit rate will be 2.5 because there are 2.5 miles in 1 hour. So basically, to find the unit rate, we are going to divide really um, one quantity per another quantity. Okay, and that number that we are going to get is going to be your unit rate because that's just a numerical part of the rate, and it means some number per one unit of another number of another one quantity per one unit of another quantity. So let's go deeper into our ratios and rates. Here is example one, our class by gender. Because we don't have a class right in front of us, we will just assume the numbers that are in our classes. So let's say in class 1 there are 10 boys and 12 girls. So how can I write a ratio of boys to girls? The word boys is first in here. So the number that represents boys is going to come first. So it's 10 to 12. Girls, there are 12. Okay, so ratio of boys to girls is 10 to 12. In class 2, ratio of boys to girls, boys will come first, so it will be 14 to 12. Okay, and let's look on the whole team. So if our team is 7-4, there is a typo in the packet. If we have two classes and we will have 10 boys and 14 boys in each class, so in the whole team we will have 24 boys, right? For the girls we will have 24 for girls. Actually, we have the same number. The ratio of boys to girls is 24 to 24. Works out just nicely. Create a set of equivalent ratios to each ratio in the table. So now we are looking at equivalent ratios. Equivalent ratios, as you remember from the vocabulary review, equivalent ratios is the ratios that mean the same thing. The values are the same. So in class 1, our ratio is 10 to 12. And I'm going to write it as a fraction this time because it's more familiar to you to find equivalent fractions. Um, and in class 2, we have the ratio of 14 to 12. And on team 7-4, it's 24 to 24. And we need to find equivalent ratios. So let's see. To find equivalent ratio, I can either divide both numbers, 10 and 12, by the same number, or I can multiply by the same number. So if I were to simplify this fraction, I would divide both numbers by 2 and I will get 5 to 6. That's one equivalent ratio, 5 to 6. I can multiply both numbers, let's say by 3. I can multiply 5 to 6 by 3 or 10 to 12 by 2. It doesn't really matter because the value is still going to be the same thing. And I will get, let's say, 15 to 18. 5 times 3, 6 times 3. That's another equivalent ratio. Okay, let's look at another one. 14 to 12. I can simplify this ratio and I will get 7 to 6. Or I can multiply both numbers by the same number. Let's do by 5, for example. 7 times 5 is 35 and 6 times 5 is 30. It's another equivalent ratio. We might not see the exact relationship between 14 and to 12 and 35 to 30, but we know that they both can be simplified to 7 to 6, and that is the same value. Okay, so these fractions are all equivalent to each other. These ratios are all equivalent to each other. Okay, on team 7-4, if I simplify this, I will get 1-to-1 relationship, or I can get 10 to 10, or 3 to 3, or 4 to 4. They're all going to be equivalent. Okay, all right, so moving on in this lesson, and we are in example 2. Which is better buy? Walmart is having a sale on pencils. A 30-pack sells for $7.97 and 12-pack sells for $4.77. Which is the better buy? Okay, in math, we always need to show your work because that's how the teacher knows that you actually know how to solve the problem. So we know that there are two relationships that we are looking at. We have 30 pack for $7.97 and a 12 pack for $4.77. How can I see which one is a better buy? Well, first you can assume, but assuming something or guessing something will not show that I know what I'm doing. So I think the best way is to find price for one pencil. If I'm looking for the price per pencil, price for one pencil, or I can make a rate of another word, remember rate, price, dollars per pencil, dollars per pencils, or pencil. Dollars per pencils is going to be rate. Dollars per one pencil is going to be your unit rate. So what I want to do is I want to divide dollars by the pencils because every fraction, every rate is also a division problem. So I will take dollars and I will divide them by the pencils. Okay. All right. So in one case, we have $7.97 for 30 packs. So for 30 pencils, so that's what I'm going to do. I'm going to divide 7 and 97 hundredths by 30. Okay. When we divide decimals, we need to make sure that we know how to follow the rules for division of decimals. Here I'm dividing decimal by a whole number. So all I need to do is to bring a decimal up and divide 797 by 30. 30 does not go into 7, so I'm going to put a 0 right on top of 7. 30 goes into 79 two times, so that will be 60. And I will subtract and get 19. 30 does not go into 19. I will bring down the 7. And 30 will go into 197 6 times, because 6 times 30 is 180. I will subtract and I will get 17. I can continue dividing to make sure that I got the good price here. 30, and I will bring 0 down here. 30 goes into 175 times. Okay, so that will be 150. I will subtract, I will make 20. I don't have to continue dividing. Guess why? Because we are working with money. And if I'm working with money, I cannot have a large number of decimals here. All I can get is 26 cents or 27 cents. And that 5 helps me to um, figure it out. 5, if you follow the rounding rules, when we have 5 or larger, this number we are rounding up by 1. So we will have 27 cents per pencil. That's in the pack of 30 pencils. Now let's take a look at $4.77 for 12 pencils. So $4.77, I'm going to divide by 12. I'm dividing the dollars um, by the pencils. I'm not going to go with the whole long division problem um, because of the time that we have here. If you need some refresher on how to divide decimals, I can help you with that on a different time. So I'm taking 4 and 77 and I'm dividing it by 12, and I get $0.40. Okay, approximately. There will be a decimal number, but approximately it'll be 40 cents per pencil. Okay. All right. So in the first case, we got 27 cents per pencil, and in the second case, we got 40 cents per pencil. Which one is a better buy? A better buy will be the first one, right? So we need to make sure that we have our answer written down. Answer: a pack of 30 pencils is the better buy. Okay. All right. Here we have a second problem, just to make sure that we understand it correctly. So Market Basket and Hannaford are having sales on soda. A 20 pack from Market Basket costs $4.99 and 12 pack from Hannaford costs $3.49. Which is a better buy? So again, we need to see, we have different amounts here. We have 20 pack for $4.99 and 12 pack for $3.49. Okay, so what I want to do is to see how much per each soda I'm going to pay. So I'm looking for dollars per soda. So when I'm looking for dollars per soda, I'm dividing dollars by the soda. Dollars divided by the soda cans. Okay, and this way I will find my unit rate. So 4.99, I'm dividing by 20 pack, and on the other side I'm going to divide 3.49 by 12 pack. Okay, so when I divide 4.99 by 20, I will get about 25 hundredths. When I divide 3.49 by 12, I'm going to get about 29 cents. So 29 hundredths. These numbers are going to tell me the answer. So here I will have 25 cents per soda. And in Hannaford, I'm going to buy each soda for 29 cents. So which one is a better buy? The one from Market Basket. So answer, soda in Market Basket is a better buy. Soda from Market Basket is a better buy. Okay, so that's how you show your work. Again, if you want to show the detailed work, you go with this one. If you want to show just what you did, you can go with this one. All right. Let's just take a look at all these different rates and finding unit rates here. Find the unit rate for each problem. So we have 560 miles in 8 hours. What are we looking for? What I want you to do all the time when you're looking for a unit rate, I want you to write what you are looking for. You can write miles per hour or you can find hours per mile. Whatever works easiest for you, that's what you do. I would put miles per hour. So to find miles per hour, I would divide miles by the hours. The word per is that division problem. So I will take 560 and I would divide by 8. 8 goes into 56 7 times and you have that extra 0. So you have 70 miles per hour. Okay, let's look at the second one. 120 words in 8 seconds. So I'm looking for words per second and I'm dividing 120 by 8, and when I do that, 120 divided by 8 will give me 15 words per second. All right, next one, 6 miles and 42 minutes. So here I will look for miles per minute. So I'm going to divide 6 by 42. Notice I'm always dividing first word, whatever I'm looking for, by the second one. And in this case, I will have 6 divided by 42, not the other way around. You can always do minutes per mile, that's fine, and you will divide 42 by 6 and you will get 7, and that's okay. But 7 will mean 7 minutes for each mile. If I'm looking for miles per minute, I will get 1/7. If I'm going to write it as a fraction, right? 6 divided by 42, I will get 1/7. 1/7, that will mean miles per minute. That means that in each minute we can walk or drive or whatever it is 1/7 of a mile. That's a big difference. So you can have two unit rates. You can have minutes per mile or you can have miles per minute, whatever works for you. Next one, I have 21 necklaces in 3 days. I want to find necklace per day. I want to find necklace per day. So I'm going to divide 21 necklaces by 3 days and I will get 7 necklaces per day. Next one, I have $5. You don't see the decimal point here. $5.48 for 4 pounds. So I want to look for dollars per pound. Dollars, and I will write it this way now. Dollars per pound. So what I'm going to do, I'm going to divide 548 by 4. And when I do that, um, let's just do a long division here so um, you can see again how to do it. 548 divided by 4. I will put the decimal point up because I'm dividing by a whole number. 4 goes into 5 ones. 4, subtract to get 1, bring down the 4. 4 goes into 14 3 times, and that's 12. Subtract to get 2, and bring down the 8. 4 goes into 28 7 times. I'm not going to continue writing, I don't have space here. But I will get 1 and 3,700. So what that number means is it's $1.37 per pound. Okay, and last problem here. 6 dozen cookies in 2 hours. We can have dozen cookies per hour. Dozen cookies per hour. So I'm going to divide dozen cookies by the hours. And that's when I will get 3 dozen. It's not 3 cookies. Notice we are looking at dozen cookies. So 3 dozen cookies per hour. Okay, I hope that wasn't too hard. Go on and do your homework, and I will talk to you in the second lesson.